All right, ladies and gentlemen, we're going to look at 12.1, exploring solids. First, we're going to talk about polyhedrons. It is a solid bounded by polygons that encloses a single region of space. But we're also, in this chapter, going to talk about other solids that are not polyhedrons. But first, we're going to look at what the definition of polyhedrons is. The polygon that a polyhedron is bounded by are called faces. The edges of a polyhedron is a line segment formed by the intersection of two faces. A vertex of a polyhedron is a point where three or more edges meet. And a polyhedron is regular if all its faces are congruent regular polygons. And somebody brought up that a regular polyhedron is like a cube because all the faces are the same. Euler's theorem is that faces plus vertices equals edges plus 2. So if you know 2 out of 3, or you can figure out the others. Again, we are going to look at the definition of polyhedrons, but we are going to explore other solids as well. Okay, so you guys have had a few minutes. I would like to see by a show of hands who thinks A is a polyhedron. Anybody? Okay, it is not, because circles are not polygons. What about B? Who thinks it's a polyhedron? Yes, it is. Yes, it is. It's a cube or a rectangular prism, depending, because it doesn't show us that all the sides are equal. Okay, who thinks C is a polyhedron? No. It has edges, it has faces that are not polygons. What about D?
Yes.
Yes. What would we call that? It's a pyramid. It's a square bottom pyramid. So you can have a triangular bottom pyramid. So it's a rectangular or square bottom pyramid. Okay, let's look at example 2. Example 2, just from the pictures, we're going to count the number of spaces, vertices, and edges. And then for example 3, we're going to use Euler's theorem. Okay, so let's start with a number of faces. Do you guys want me to get out the 3D shapes? Let's look at the 3D shapes. Because some of you guys, I know some people have a hard time seeing the 3D from the 2D. Excuse me, dear friend. And these shapes are going to be useful as we talk about surface area, volume, lateral area. Okay. So we are looking at here our square bottom pyramid. Okay, that's what A is. And I'm holding up this 3D shape. And we are going to list faces, vertices, and edges, the number of each. Okay, so if we're looking at our square bottom pyramid, we've got 1, 2, 3, 4, 5 faces. Okay, vertices, how many points do we have? 5, good. And edges, we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay. We are looking at what looks like, I like to think of it as like a stick of butter. It's a rectangular prism. Looks like it has square ends. So how many faces do we have here? 6. How many vertices? Yeah. And how many edges? So we got 4, 8, 9, 10, 11, 12. Okay. Now we're looking at a triangular, I don't know if I have one of these. It's a triangular prism. So it's a right triangle, which I do not have a right triangular prism. I have a triangular prism, but not a right. Okay, so let's talk about this. How many faces do we have?
5.
Okay, let's talk about the vertices. We've got 1, 2, 3, 4, 5, 6. So how many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 8? Okay, I double counted.
That's a 5.
That's a 5. All right, this is a what we call hexagonal pyramid. I was right?
Yeah.
How many edges? 1, 2, 3, 4, 5, 6, 7, 8. Oh, I was right. 9. Thank you. Okay. So we've got faces, vertices, and edges here as well. So how many faces do we have? We've got the bottom, right? So we've got 1, 2, 3, 4, 5, 6. We've got a total of 7 faces. Okay, how about the vertices? I know I have 1, 2, 3, 4, 5, 6 on the bottom, plus 1 gives us 7. And the edges, we've got 6 on the bottom. 7, 8, 9, 10, 11, 12. Okay. All right, let's do this using Euler's theorem. For example 3. Okay. We are going to calculate the number of vertices of a solid given that it has 10 faces. So we know Euler's theorem is faces plus vertices equals edges plus 2. And we want to find the number of vertices if we've got 10 faces. So how many edges would we have if we have 10 faces? If they're all triangles, so we've got 10 triangles. So how many edges we'd have? 30, right? So we'd have 10 plus the vertices equals 32. Subtract 10. We'd have the number of vertices we'd have would be 22. Okay. Look at number 2. We're going to calculate the number of vertices of a solid. Given that it has 7 faces, 2 of them are pentagons and 5 rectangles. Okay, I've got to draw this picture. So I've got a pentagon at the top, and I know I'm going to draw another pentagon below it that I'm going to pretend Miss Murphy's a great drawer and it's identical. Okay. So I know that it is faces plus vertices equals edges plus 2. I know 7, 8, 9. I've got 9 faces. I don't know how many vertices. Let's figure out the edges. So I know I've got 5 on the top and 5 on the bottom. So that gives me 10, 11, 12, 13, 14, 15. 15 edges. So I've got 9 plus the vertices equals 17. So I subtract 9 from both sides. And the amount of vertices I have is...
Why is it 9? Because it has 7 faces.
Oh. So I try to count things together. 7 faces. So I'm going to subtract 7. So the number of vertices it has is 10. Let's see if that's true by counting. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Feel okay about this? 15 edges, I counted them. So there's 1, 2, 3, 4, 5 at the top, right? And 5 at the bottom. And then where the rectangles meet each other, that's another 5. Right? 1, 2, 3, 4, 5. Okay. We are going to read now.